Our next panel is already up here. So I would like to introduce Jitendra Malik, who will be our moderator for the Human-Centered AI panel. And I should mention that our afternoon panels got to be a little smaller than originally intended. There are, complications in the world. But we have such great people that it's actually nice that we'll have more time to talk with these wonderful panelists.
Thank you. Thank you, Jennifer. Let's can people hear me in the back? Okay. So this is a great time to be in AI. Personally, I started in AI in 1980 as a student of John McCarthy. And at that time, AI people were tolerated in computer science departments as some folks who were off on the side with doing some silly stuff, and it wasn't going to hurt anybody because it was never going to be real. And we have come a long way since then. And of course, the current wave, which is sparked by deep learning, it really goes hand in hand with big compute and big data. And we have had tremendous accomplishments in fields like computer vision, and where there are these data sets such as ImageNet developed by Fei-Fei, where if previous performance was like 20%, now it's like 90%. So tremendous improvement over the last many years, which has enabled a lot of applications fielded by various tech companies and other people. We have had major advances in natural language processing, machine translation, speech recognition. I mean, these things, when you tried them 10 years ago, they were basically annoyances. So whenever I would go on one of these airline booking systems, and you wanted to say operator quickly so that you got out of that stupid computer program as fast as possible. And that's not true now. We can actually get work done with these systems. Of course, the general public sees discussion of winning at DeepMind systems, winning at Go, and so on. And then you even hear all these things about AGI, and then the singularity will happen, and then maybe these intelligences will decide that they don't have any use for us anymore. So I don't want to talk about AGI. We'll have more to say on that later in this panel. That's not the primary subject here. I think it's a bit far-fetched for now. There are other topics which we could discuss, but for which this panel is not the most competent, which is the economic consequences of AI, which is consequences on employment and so forth. And we did have a panel earlier which was populated by economists, so I think we touched on some of those topics there. Let me just say some general things, and then I'll turn to the panelists. Whenever there are major advances in science, then they get followed by advances in technology. And this is just the way it is. I mean, there were advances in chemistry followed by chemical engineering in the end of the 19th century, and molecular biology followed by various kinds of drug developments based on that. So AI is no different. I think you should think of it like any of these other areas where there was a whole lot of curiosity-driven work first, and then it comes to the point where there are several applications which help real human beings emerge. And then we get to the point that it starts affecting society in various ways. So governments get concerned. Maybe they are concerned about it just from the point of view of making money off it. There's this famous line from Michael Faraday about what use is electricity, and he told the king, one day you will be able to tax it. So that's certainly a reason. But of course, there are very good reasons why policy people need to care, because there is an impact on society. So we'll try to touch on this, and just like any other technology, we developed technology to help human beings. We developed mechanical power so that human labor could be reduced. Similarly, the developments in this broad umbrella of AI are meant to help human beings. They are not for their own sake. So I think it is human-centered AI is the topic of this panel, but all AI is human-centered in that sense, because we do curiosity-driven research, but our ultimate goal is that. Okay, so now I'll turn to our panelists, who will, and we'll start with Fei-Fei, who is a professor at Stanford. Her research is in computer vision, in robotics, machine learning, and she did pioneering work responsible for this revolution by creating ImageNet. She has received many honors, including National Academy of Engineering, National Academy of Science, American Academy of Arts and Sciences, and there's a long list that we could spend the next hour discussing. But very importantly, she is at Stanford, they have an institute which is on human-centered AI, and she's going to undoubtedly tell us about it. But she has played major roles at the national scene, including being one of the 12 people who are on the Biden administration National AI Resource Task Force. So I'm going to turn to Fei-Fei, and I'm going to ask you to tell us what human-centered AI should be about, or what is the Stanford view on this?
Yeah, thank you, Jitendra, and thank you for the invitation. Jitendra did warn me I have to be careful since I'm talking to a Berkeley moderator. So I guess I'll share my thoughts wearing two hats. One is an AI researcher, which is the foremost identity I see myself, as well as the co-director of Stanford Institute for Human-Centered AI. Jitendra mentioned that many of us here entered the field of AI when it was still so niche. It was so niche, it was just a corner of most computer science department. I guess Daphne and I literally had office next to the office used to be occupied by John McCarthy. And in my career, I entered this field literally 2000, right? So the turn of the century, fast forward 2 decades, this has become so huge, as Jitendra described, that the evolution of this field has become so huge and horizontal that suddenly I spent some time in the past few years thinking, what is the framework we should think about AI? AI as research, AI as a technology, AI as an enabler to the society's transformation. And I personally believe human-centeredness is one very powerful way to frame AI and everything we do. And at Stanford, Human-Centered AI Institute, which we call HI, Stanford HI, we put 3 elements or 3 pillars centering around this concept of human-centered AI. The first one is recognizing this is no longer a niche, small discipline. Recognizing AI has grown into a horizontal technology that will impact and transform our society and human lives. By recognizing that, we should first put incredible amount of investment and care in understanding the human impact so that we can anticipate it and guide it. And this is where even at Stanford, a lot of work with the digital economy, geopolitics, governance happen. It's that interdisciplinary recognition of the societal impact of AI. The second pillar of human-centered AI that we see is actually about a verb. The general public hears about AI, and the first verb that comes to mind is the verb replace. But for us, what's really important is to actually replace this verb, replace, to call it augment or enhance. At the end of the day, starting with the discovery of fire to the innovation of AI, technology is to serve human well-being. So how do we use this technology to enhance and augment both the productivity as well as the well-being of humanity is what we focus on. The third and last but not the least is that, and I hope all of you chime in here, we really need to recognize this is still a nascent field. As a science discipline, AI is still so young. There's so much more to be discovered, to be innovated, that we believe by incorporating human brain and human cognition and human behavior inspired science will fundamentally propel AI technology into a new level. The reason we put humans in the center of this is because we want this technology to work with humans. Therefore, understanding and collaborating with humans is very important. So just as a quick example, as an AI scientist, my lab now works at the intersection of all three pillars. In robotic and computer vision learning, we look at curiosity-driven learning. We actually look at human behaviors and work on robotic projects that are assistive technology for human activities like household activities and so on. And for enhancing, another example of enhancing humanity is healthcare. We work in healthcare delivery to enable smart sensors, smart cameras to serve as guardian angels for our vulnerable patients to ensure safety while respecting privacy. I'm happy to dive deeper later, but I just want to, this is kind of my overarching statement about what human-centered AI is.
Thank you, Fei-Fei. Okay, next we turn to Daphne. So Daphne is currently the founder and CEO of insitro. Before that, she was founder and co-CEO of Coursera. And all along, she was also a professor at that other university, Stanford. And Daphne is a certified genius. What do I mean by that? Well, the MacArthur Prize is called a Genius Award, and she does have it. And in addition, she has the baby Turing, what I think is called the ACM Prize in Computing, but I like the nickname better. And member of the National Academy of Engineering and various other things which I will skip in the interest of time. But I'm going to ask Daphne specifically to talk about the role of AI in scientific discovery and specifically biomedicine, because that's what she does.
Thank you, Jitendra, and thank you to the organizers for inviting me to be here. So I find it interesting that we have 3 generations, probably 4, represented here, because if Jitendra started his career in AI in the 1980s and Fei-Fei was in 2000, I was in 1990s, so
yeah.
smack in the middle.
Yeah.
And I still remember the days when where AI people were not actually really tolerated, where people had to go. This was in one of the many AI winters that we've all had to face, where people used to say they did cognitive computing because doing AI was not a respectable thing to do. And so I lived through several of those, which is actually one of the reasons, and we'll come back to that later when we talk maybe about AGI, Jitendra, that I have a deep aversion to hyperbole and hype, and we can discuss that later. So I started my career in AI and machine learning in the 1990s, and I actually started my career in computational biology and computational medicine in 2000. So about a decade later, as the first what we thought of as large data sets in biomedicine were starting to emerge. And at that point, large was considered, if you had a couple hundred samples, you were excited because this was considered a large data set. And frankly, compared to the data sets that were available to machine learning people at the time, like predicting spam, or I don't know how many of you remember the 20 news groups. These data sets were more interesting and larger than we had at the time for other applications. And so that was back then. And then, of course, if you fast forward some number of years beyond that, 12 years, ImageNet, thanks to Fei-Fei and others, and of course, the world of machine learning became the incredible beneficiary of increasingly large, rich, and high-value data sets that have driven much of the progress that we've seen in artificial intelligence and machine learning over the last decade or so, where this incredible sort of energy well provided by these large data sets have enabled the predictive power and the ability to extract insights about various application domains has really arisen from this availability of large, high-quality data sets. And that was not throughout most of my career the reality for science. Data sets in science were small and bespoke, ridden with artifacts, usually the aggregation of all sorts of little bits and pieces of data, none of whom were particularly good in the first place, but glommed together in a way that really made it very difficult to tease apart artifacts from signal. And so it was really hard to do machine learning in service of science until recently. And I think we're now at the cusp of actually we're in the midst of an inflection point when it comes to machine learning in service of scientific discovery broadly, and specifically scientific discovery and discovery in the context of biology. Because we're now in a world where data are becoming abundant and tools for generating data are becoming much more democratized and available. So let me talk a little bit about each of these. There are now, in the context, for example, of human health, increasingly large and valuable data sets about humans, about patients in hospitals via electronic health records, in national biobanks, in various countries, which gives us, for the first time, the ability to study human physiology, human biology, and human disease in a way that is driven not by hypotheses, but directly arising from the data. There are, on the other side, incredibly talented cell biologists, bioengineers, biochemists, multiple other disciplines have come together to produce tools that are data generation engines. These include things like the ability to use CRISPR to knock out or amplify the activity of each gene in the genome across different types of cells and different types of systems, and observe in incredibly rich ways what happens to those cellular systems when you intervene, and what does this gene actually do? We can actually measure that for the first time in a scalable way. Experiments that used to take 3 years to set up and use to measure for whatever, half a dozen genes, you can now do in a couple of weeks genome-wide across multiple cell lines. So all of a sudden we're faced or have the opportunity to study mountains of data, tidal waves of data, and what we need are the commensurate tools to extract the kind of insight from those data that can really drive our understanding of the world around us. And that's where machine learning, I think, and an AI can really play an incredible role. So I actually think that specifically when it comes to biomedicine, we're entering the era of what I like to think of as digital biology, where we can measure biological systems at an unprecedented fidelity and scale, interpret those data from using the tools of machine learning and artificial intelligence, and then go back and engineer biology to do something that it wouldn't otherwise do if it left to its own devices. And that has implications across a spectrum of different ways, coming back to the topic of this panel, human-centered AI, that can help make the world a better place for humanity. The work that we're doing is in the context of human health, but I think the ramifications are equally profound in other areas, including agriculture, including biomaterials, energy, environment. All of these are places where we can finally start to engineer biological systems to do something different that is better in terms of the world around us, and maybe solve some of the most pressing societal problems that we have around us, including disease. And obviously, I think actually this COVID pandemic is the first example of a place where we have actually engineered medicines for the first time. These are not medicines that were discovered, they were medicines that were engineered. And I think that there's similar potential impact in other parts of human endeavor. And so I think this is going to be a really great era for machine learning enabled scientific discovery.
Thanks, Daphne. Okay, now I'm going to turn to Raquel. So our next panelist is Raquel Urtasun. She's a professor at University of Toronto. She's one of the co-founders of the Vector Institute for AI. And she is I've known her for a long time when she was a computer vision researcher, but she's been in computer vision, machine learning, but lately into self-driving cars. And that's her passion. She was chief scientist at Uber, and now she's been the founder of Waabi. So tell us, are we going to have self-driving cars?
$1 billion question, I guess. Thanks, Jitendra, and thanks the organizers for inviting me. And I'm honored to serve with an amazing panel. And I feel like I should, kind of lose 10 years to be the fourth generation, but unfortunately I'm not. I actually started at the same time, same year as Fei-Fei, so.
You just look a lot younger.
Not anymore with this pandemic, anyways. Anyway, so as Jitendra said, I work in self-driving. I've been working on it for the past, over a decade now, and more than, I guess, 20 years in AI. And, for me, self-driving is really an obsession. It's something that, before I retire, it has to be solved. So to your question, it's happening, it's going to happen. It's just a matter of building the right technology for this to really bring it to market at scale. And in terms of why is self-driving an obsession, is because, fundamentally, it's a very hard problem to solve, right? As a scientist, it's very exciting to try to build new technology that, nobody knows what the solution is, right? At the same time is, something that is going to really impact the world, right? There is no question that there is so many benefits to our society of self-driving. It's not necessarily going to displace jobs, it's also going to create jobs, right? But more importantly, it's going to bring safety, for example, to our roads. It's going to reduce some of the logistic issues that we see today. It's going to provide transportation for people that right now do not have mobility, right? It's going to environmentally provide us with, saving fuel and, maintaining some of the resources of the planet that's so important for the generations to come. So all these things make it, a very, very exciting field to work on. And if you look at the evolution of self-driving, right, it's been a lot of talk about for the past, 2 decades since the DARPA challenge, right? And there has been some pretty exciting, developments. But when you look out there outside San Francisco, you don't really see anything out there, right? So the promise of self-driving is next year, next year, right? Continues to be pushed to the right? So, and to the core of it is the fact that it's a very difficult problem. And at the same time, there is a need for new technology, new AI. It's not that you can take, existing tools and, magically you're going to solve this task. So it's pretty, I would say, it's a pretty exciting field, and definitely, something that is gonna help us. And just as a motivator, so despite all the advances of technology, this year in the U.S. there were more deaths on the road than since 1975. So I will leave you with that statistic, which is mind-blowing to me, because there is so many ADAS systems, there is so much technology that is going, but however, there is more and more deaths. So there is definitely a lot that scientists we should do in order to prevent this.
Thank you. Okay, so now we'll move to general discussion and general questions. So my first question is going to be about the following. So part of, this is one of these aspects of growing up, or when kids leave the home and go out into the world. So when AI was this academic discipline, we went about it in a certain way, and now it's huge. And it seems that a lot of AI research right now is conducted in the big tech companies. The Googles, the Metas, Amazon, Microsoft, and so on, because these companies have the compute resources, they have the data, and they have the person power to put on the problems. But as companies are supposed to do, they're supposed to maximize shareholder value, and that is a certain bias in the system. And we would normally want to think about the entire ecosystem. So in the United States, you would think about universities, you would think about companies, you would think about government, you would think about non-profit organizations. And somehow, for the success of the field and for its application for human enhancement or augmentation, we really do want a balanced ecosystem. And I'm going to turn to Fei-Fei first, and then I'll ask others what's missing now and what should be done. And you are supposed to be on this Biden panel, so you're supposed to know the answers to these questions.
Well, I think you said the right word, Jitendra. I think the US economy, especially our innovative technology and leadership in the past more than half a century, almost a century now, is because of this incredible ecosystem between the multi-players, from the government to the public sector, academia, and incredibly entrepreneurial, industry. And this huge suction sound and force in the recent few years, where compute, data, and talents are so concentrated in, it's not just industry, it's in a handful of companies, most of them in the Valley, is actually not doing the future a service. I think it's really important they're part of the players and part of the ecosystem, but blue sky research, curiosity-driven research, multi-stakeholder, multidisciplinary research about the implications and social impact of AI, research about technology and democracy, research about rare diseases that might not have an immediate economic return. All this still need to happen. That's how our economy would have been propelled in the past few decades. So with that in mind, the Biden, it actually started in the Trump administration. Stanford was part of the forces lobbying for this bill that will rejuvenate and revitalize this ecosystem by government injecting more resources into public sector and higher education. So this task force I sit on for the past, I guess, 12 months and 6 more months for this entirety of 18 months, our goal is to figure out a plan to present to Congress how we can collaborate with the industry to create a national compute and data resource to enable AI research and education, with keeping in mind how we support a diverse representation of players, especially traditionally underserved universities, institutes, and nonprofit organizations, and also to pump in more resource for public sector and AI for good, AI for society research. So I genuinely believe the industry leadership is great, but we also need higher education and public sector participation, and in certain cases, leadership in this.
Thank you. So Fei-Fei has addressed something which I think within the AI research community is discussed a lot, which is how do we make this ecosystem broader and more inclusive. But if I were to watch Hollywood movies or look at some of the stories in the press, the concerns about AI spring from an entirely different direction, and which has to do with AGI. So of course, there will be these machines and which will become more intelligent than us, and they may not need to have us anymore. So that's one version, and the other version is we just need to build this AGI and then it can solve all of these problems. I have the feeling that Daphne may know the answer to this.
I can't claim to know the answer, but I can have an opinion. So I think AGI is an interesting goal. It's certainly an exciting possibility, promising to some, threatening to others. I'll say that I don't spend too much of my time worrying or dreaming about this potential, because I don't think it's anywhere on our horizon, and I know some people disagree with me. I think that there are far more pressing things for us to worry about on the immediate horizon that we really should be focusing our attention on. Like, for example, climate change is a great example of a thing that is much more on our immediate horizon and that we should be worried about. And so in that respect, I'll actually mention an incident that I happened to be listening to a talk by someone, and part of their narrative was that, well, we really shouldn't be spending too much time today worrying about climate change, because the right way to tackle climate change was first we build AGI, and then the AGI will figure out how to solve climate change. And let me just say that I don't personally believe that that is the most direct path to addressing climate change, or the one that's likely to give fruit in the most immediate time horizon. So I would say if you want to solve humanity's most pressing problems, whether it's human health or climate change or food shortages or anything else, you probably should be thinking about how to deploy AI towards those goals in the most direct possible path, rather than going through AGI.
Perfect, thank you. I will editorialize here. I know I'm the moderator and shouldn't editorialize too much, but I have the feeling that if you actually talk to AI researchers, the people who are actually doing the work, how many of them worry about AGI and existential risk? I think the answer is probably definitely less than 1%. Okay.
Well, there's no definition.
Yeah,
I mean,
because it's this vague concept which and actually the more serious thing is that talking about that detracts from the real issues today and the real issues of the application of AI. And I'm going to make that a general question, and maybe starting with Raquel, but everybody, which is, what is the role of policy? What is the role of governments? So let's say, let's take self-driving cars. We have regulations on what kind of a car you can drive on the road, right? It should not pollute, for example, and the brakes should not fail, and you shouldn't kill people and so on. So the introduction of technology in settings, and it could be self-driving cars, it could be about using them for deciding on whether somebody gets bail or somebody gets a suspended sentence. There are many applications of that, and the question is, how should we go about addressing those questions? So I'll ask Raquel first, but this is a question which is of general interest, so each of you weigh in.
Yeah, we'll give quickly my take so that you guys can also chip in. Regulation is very important, but regulation shouldn't be a blocker to development of technology that is really gonna help us in the future. It should be a way to make sure that that development is safe and it gets us there in the right way. And that's easy to be said, pretty difficult to do in practice. And from my experience, one of the main issues comes from the fact that regulators are not experts. So they don't understand this technology in the first place. So it's really hard to regulate something that you don't even know what it is, right? So a lot of this is about conversations, it's about education. It's about how we regulate so that we can bring this technology in the way that it's supposed to be brought, right? But that's a pretty, I guess, loaded question, I will say.
So I live in a heavily regulated industry, which is that of healthcare, and we all hear about FDA regulators and so on. And I think that this is an important balance for regulators to keep when you think about AI, machine learning, and healthcare. On the one hand, there's clear examples where there has been under-regulation in the sense that people have not appropriately vetted claims about AI tools that have been deployed in healthcare environments to make sure that those tools are actually safe, equitable, sufficiently high accuracy, and it's an area where it's very easy for a wrong recommendation given to a clinician or to a patient to have potentially quite severe consequences. And so I think this is a place where, in the same way that we regulate other forms of drugs and medical devices, one should think about an appropriate review standard for some of the machine learning tools. On the other hand, I think there is also cases where some of the tools are held to an overly high bar, which is to say, well, we need to exactly understand what's going on underneath the hood, otherwise it's not, it's not transparent enough and it's not clear. Well, when was the last time you had transparency into the mind of your clinician when your clinician made a diagnosis? So in some sense, you're holding the machine to a higher bar than you're holding a person. So I think it's important to have a regulatory process for these tools, but I think it's also important to have that be a bar that is reasonable in the sense that you're not requiring more of those tools than you are requiring of other forms of intervention that don't use machine learning just because it has that scariness of, oh my God, this is a machine learning tool.
Yeah, I definitely agree with Raquel and Daphne. Wearing my high director hat, I think about policy and government a lot, and I already showed you an example of incentivizing AI ecosystem through policy. There's the regulation. The thing that I want to highlight is what Raquel also said, is that dialogue and education is hugely important. This is a rapidly moving technology that for many policymakers from local to state to national level, this kind of came out of blue. And it's very hard for them to understand what this is. So before we even point fingers or talk to them, tell them what to do, we really need to engage. Silicon Valley has not done a great job in engaging with East Coast, Washington, D.C. At Stanford, we are holding a lot of boot camps for congressional staffers. We are going to the D.C. to talk to the caucuses in the Senate, in the Congress, in White House, in the departments from commerce to defense to education. We're talking to agencies. This process is so important, and with the audience like ACM, I think we actually have a role to play. We come from being educators. We know how to communicate this technology, and we're part of the stakeholders. So I think that the role of education and communication in policy making in AI is critical, and it's a critical historical moment to do that now.
Perfect. So what's the protocol for when do we take audience questions? Is it now? Okay, so Jennifer is going to give us audience questions. Is it sorted? Okay. Oh, this is clearly an amateur philosopher here. Okay, but if I were the owner of a human-centered AI self-driving car, should I be able to instruct the AI driver how to resolve the trolley problem as I wish? Oh no.
Okay. We're going to leave that to you.
Okay.
Meaning that you want to be liable for your self-driving car. I think the situation is not that you own a car, that we actually share the resources of the planet, okay? But you can have a service where you actually call your vehicle. I think there is a lot of debates about the trolley problem, and I don't want to necessarily remove the importance of the trolley problem, but at the same time there is more important pressing matters right now in terms of that we need to solve for deployment of self-driving vehicles. That is where we are actually focusing our effort on. Okay, but after the panel, happy to talk and philosophize about it.
Okay.
I invite whoever asked this question to come to HAI. We actually have philosophers and legal scholars debating about this.
Okay, I have another question which is actually very concrete, and I'll ask Fei-Fei first and then I'll answer it myself too. How long until there is a robot that can take care of an elderly adult 24/7?
I literally, we are writing for a deadline in robotic conference as we speak now. I just this morning, a student literally sent me a quote of a AI researcher 10 years ago who said that this will happen in a few years. Clearly, we're not there. As a scientist, it's very hard to put a day or a year, but I can tell you this is a very, very hard problem. It's one of those problems that converges on understanding, perception, planning, possibly neurosymbolic representation of the world, as well as communication with the human elderly. It is, in my opinion, one of the most exciting and impactful and profound problems that we can work on as a field. It's also one of those problems that I believe academia is leading, because it's not a problem that will generate immediate revenue yet.
Yeah.
But a lot of labs, Jitendra's, ours, and many more, are starting to really pour the intellectual investment into this problem. It's very exciting. I hope it's in our lifetime.
I concur. I wanted to add that unfortunately, we had a fourth panelist who was Rodney Brooks, who unfortunately had to drop out at the last minute because of COVID. But Rod Brooks runs a blog where he has predictions on various dimensions. And he says 5 years, 10 years, not in my lifetime. You may agree or disagree, but I mean, he's in the prediction business. I try to stay out of it myself. I think because I follow the line from Niels Bohr, it is difficult to make predictions, especially about the future.
That was Yogi Berra.
It's also Yogi Berra, but it probably did not plagiarize it from Niels Bohr. But even before we get to that stage, the 24/7, there are a lot of things that a home robot could do. So I think it's probably true for both Fei-Fei and me. I want to have a robot in my home which does something useful at a price point that regular people can afford. And I think that we could get there and be useful even if the robot cannot take care of an elderly person 24/7, because that requires great physical ability, emotional intelligence, many, many dimensions. But I think you could be useful without that. Okay, last question. Is that fair? What education or training should AI students receive on human-related topics, such as biology, anatomy, social science methods, etc., to be prepared to take a human-centered approach to applying AI? Good question.
Coursera co-founder?
I think that AI and machine learning are permeating everything around us, and the greatest impact that this technology can have is actually at the boundary between disciplines. And so I would encourage that at least a subset of our students be trained in the application areas where they hope that they will be able to make an impact. Because I can tell you that there's a lot of naivete among students trained in AI, and I would say maybe in technology more broadly. It's like, we're gonna come in, we're so smart, we're just gonna solve it all. And the truth is, you really have to understand your problem domain to make a difference. So I think that there is an incredible value to people to have enough of an understanding so that first they can converse with their counterparts in the disciplines in which they're going to be working, and also to develop a certain level of humility about how hard it is to solve some of the problems that they're looking to solve, because there's a certain hubris that comes with being in this field that has had so much impact that I think often causes us to become overly arrogant and make some very, potentially some problematic mistakes. So that is one part, and then I'll maybe turn it over to Fei-Fei to talk about some of the more humanistic aspects of human level AI.
Yeah, thank you, Daphne. To all the students and educators out there, if you or your student want to do AI, I really urge you to take an ethics class, especially those embedded ethics in technology. And I want to really give a shout out to Harvard, Professor Barbara Gross, who was one of the first computer scientists who designed embedded ethics in computer science curriculum. Stanford did follow her footsteps. We have a class for our undergraduate to take is ethics policy and technology. So if your university has a class and you are passionate to become a technologist, whichever discipline application area, please take an ethics class. If your university does not offer one, this is where you should write to your president and ask for such a class. It's so important for this moment that we have that kind of interdisciplinary training.
And on that note, I thank you all for listening, and it's been a wonderful moment for us.
Thank you.